Welcome to Simply H2 Math video series specially made for JC students. I'm Mr. Song from Learning Simplicity.
Welcome to the final video series on functions. Today we are discussing about composite function. Supposedly we have a composite function of f gx, where gx is substituted into the function of f. So it's formed as collaboration between the two functions where g is sub into f. So let's look at the mechanism of this composite function. So for this composite function, we start out with the domain of g. So under the mapping of g, we have the range of g. So this range of g must be inputted into the domain of f. For function of f alone, under mapping of f, it will be mapped onto the range of f. But since it's a collaboration effort, whatever is in the range of g now will be inputted under the mapping of f to form the range of fg. So the range of fg, I can see from the bubble diagram, is always a subset of range of f. So it's clear from the diagram that for the domain of fg, it will be essentially the domain of g, because that's the starting set of domain for this composite function. To find out if a particular composite function exists, especially in this case of fg, we need to determine if range of g is a subset of domain of f in order for the collaborative effort of this composite function to carry on. The range of a composite function it can be determined using the mapping method. Mapping method is a method whereby you look at each function individually to determine the resultant range. So let's consider the function of fx equals to minus x cubed. X belongs to real number. Gx equals to e to the power of x, where x belongs to real number. So to start off with, we look at the domain of g, which is all real numbers, from minus infinity to infinity. So under the mapping of g, we have the range. So the range, as we have mentioned, we can always try to find out using graphing. So using the graph under the domain of all real numbers, we can look at the range. The range will be from 0 to infinity. So this is the new domain for your f. So remember, it's a collaborative effort between g and f. So again, we got to draw the graph of fx. So the graph of fx, remember, is minus x to the power of 3. So using this new domain, which is from 0 to infinity, the output or the range of this function will essentially be from minus infinity to 0. And this set of values is the range of the composite function fg. This is how we can find a range of fg using the mapping method. Of course, you can also try to find out the function of fg, the equation of fg, using the domain of fg, and then draw the graph. Hope you have enjoyed and benefited from the final series on composite function.